right, good morning. Hope you're all doing well. Good to see all of you. If a few of you could turn on your video, I'd appreciate that so I can make sure things are set up correctly. Are you able to see the boards okay? Someone somewhere respond. Are you able to see the boards okay?
Yeah, we can see the boards.
Okay, thank you. All right. Well, I do have some announcements, but I'm going to hold off on those until a little later. People are still joining late, which I don't appreciate too much because I do want to give the announcements at the beginning and I do want to start on time. So we are going to start the trigonometry finally, and this is what I really want to get to before the end of the year. So we are here and we're in lesson 17.1. And I have probably 15 pages of notes. And so it's going to take me a while to teach this lesson. All right. In addition to that, you are going to have a quiz on vocabulary. There could be a quiz on graphing an angle, naming an angle in standard position. So this might be different than anything we've ever done in class or online because there's a lot in 17.1 where I'm laying the foundation of the unit circle. So today, when I start this lesson, I'm going to be giving you vocabulary, and I do recommend that you put it on an index card and you put the term on the front and the definition on the back. I'm going to be very strict about these definitions. The definitions do have to include specific words. In other words, you can't just put it in your words and leave off an important word in the definition. I was going to give you an example, but I'll just wait until I get to it, I guess. Let me think if I could think of one. Okay, for example, the definition of an angle in standard position has two conditions. The first condition is that the vertex must be at the origin. The second condition is that the initial side must lie on the positive x-axis. So if you leave off the word positive, you will get that wrong. Because it's critical that in the definition that you write the positive x-axis because it can't be anywhere on the x-axis. So when I write down vocabulary, you can use index cards, you can make your own index cards, but you will be quizzed on this and the quiz will be incorporated into your exam grade for lesson 17.1. So let me just tell you this much. If you do not understand the vocabulary, it's going to sound like you're taking a French class and you're not going to understand anything I'm saying. So when I teach this lesson in 17.1 and module 17, I'm going to be using vocabulary, and it's critical that you understand what it means. All right, so you must understand the vocabulary. That's why I'm asking you to put it on index cards, and that's why I'm asking you to make sure you know it, and I'm quizzing you on it at some point. All right, so let's get started. Lesson 17.1, basically, we're going to look at angles of rotation and specifically radian measure. I'm just letting you know that you have to know how to measure an angle in radians. And normally I take an entire day to do an exploratory activity on what 1 radian is, but we can't do that. It's very critical that when I talk about 1 radian, that you understand what it is. Because you're going to have to name angles 2 ways. You're going to have to name an angle in degrees. We normally don't do that. You did that in geometry. So we're going to be graphing and naming an angle in radians. So that's going to be a very important term, and you're going to have to know what that is conceptually. All right, so let's get, the explore is super important. All right, if you don't do the explore this time, It's loaded with things that you need to know, and unless you've taken a trigonometry class before, every single person needs to do the Explore. All right, so the first definition we're going to have is an angle, and a lot of times you're going to see me use that symbol. I know you've seen that in geometry, hopefully, with Ms. Fresco. Mr. Johnston and I disagree with the definition of this, so of course I'm right and he's wrong. I'm just kidding. But my definition will fit with everything you're doing. So my definition is, it is a ray rotated about its endpoint. All right, so that's the definition that I'm going to give. Mr. Johnston can tell you his. Someone has their microphone on. If you could turn it off, that'd be great. So I'll show you an example of this from geometry and elementary math. They've been talking about this for a while. Array, part of a line segment. Yeah, it ends on one end and it extends forever in another direction. So that would be array. And then when you rotate the ray, so I'm going to rotate the ray and end up with the ray being over here. I need, okay, whoever has their microphone on, I need you to turn it off. So I have several people with your microphone on. If you can scroll to the bottom, please, and turn the microphone off. I'm getting a lot of feedback. All right, so anyhow, so this ray, and we're going to call it, then these are, I'm going to throw a bunch of terms at you here. This is called the initial side. And this is called the terminal side. This little arrow is showing the rotation. So when I have you draw and name an angle, you're going to want to show the rotation, because this rotation, I'll get into it, this rotation counterclockwise is going to dictate a positive angle. And rotation going clockwise is going to represent a negative. And I'll get into that. But anyhow, I'm going to call this angle theta, which is a Greek letter. And you're going to notice that I put the Greek alphabet in your video and notes. So you have the Greek alphabet now. It's already in there. You're going to do this because this is how we're going to name angles in geometry. We name angles with capital letters ABC, and in trigonometry, we label them with Greek letters. Now, I'm going to be getting into all this, so don't be worried about writing. I'm going to write all of this down. So I'm kind of just, talking right now. Okay, this point right here that the ray is rotating on is called the vertex. So a lot of vocabulary here, but I will write it all out for you, and I will write it out all very precisely. But this is just the angle. So an angle is the rotation of a ray about its endpoint. It has an initial side. It has a terminal side after rotation. This is the angle right here. This shows the rotation. This names the angle, and this is the vertex. So with that, I'm going to break this down a little bit. So the definition of array, it's the part of a line that has one endpoint and extends forever in the opposite direction. So on one side of one index card, you'd have angle, and that definition in the back of it, and go through it, make sure you know it. ray in the definition, part of a line that has one endpoint and extends forever in the opposite direction. Let's look at the initial side. You saw me write it here. The definition of the initial side is the starting position of the ray. We have the terminal side. You'll probably guess it's the ending position of the ray after rotation. So Mr. Johnston's definition, his definition is two rays with a common endpoint. It's not two rays, it's one ray that's being rotated. And so all my definitions are going to fit this definition. So it is the rotation of a single ray. The initial side is the starting position. The terminal side is the ending position of the ray after rotation. And then the vertex is the end point of the ray. I would not sway too much away from these definitions. Lots of times it's okay to put your own words. I don't care if you put your own words, but don't mess up on the keywords. So you have to make sure that you have the keywords in these definitions. I will not have the computer grade this quiz. I will be grading it by hand. And the grading by hand is something that I'm going to explain when I talk about some notes on the exam you took on Monday. Teach one more section here and then I'll go over some housekeeping things. In one of your exercises, so when you go to lesson 17.1, you're going to see 4 links. You're going to see a lot of work. You're not going to be able to, you have to do the work as I assign it. So I'll tell you what to do. Right now I'm telling you to do the vocabulary words. All right, so it'll be a progression of things that I want you to do because there's a lot involved here. All right, the next term is position. Okay, an angle is in standard position if 2 conditions exist. The first condition is, like I said before, if you heard me, the vertex is at the origin. The keywords here are vertex and origin, which is 0, 0. So for an angle to be in standard position, the vertex must be on the origin. The second condition for an angle being in standard position is the initial side lies on the positive x-axis. So the initial side, remember, is the starting position of the ray. It has to lie on the positive x-axis. So this problem will be in the vocabulary quiz. It'll be worth 2 points because of the 2 conditions. So let me show you an example of this. I'll do 2 examples. Make sure also when you draw and name an angle in standard position that you label your coordinate plane. Mr. Johnston's real strict about that in calculus. And so if I were going to draw an angle, the vertex must be at the origin. The initial side lies on the positive x-axis. And if I were going to show a positive angle, I could rotate the ray there. And that would be a positive angle alpha in standard position. If I want to draw a negative angle, I haven't gotten into that yet, but I'm just showing you. And I show the rotation clockwise. Let's say I call it beta. That is a negative angle in standard position, and his name is beta. So this is angle alpha, this is angle beta, this is a positive angle, that's a negative angle. Make sure that when you draw and name an angle in standard position, you show the ray and the rotation with the arrow, and you must name the angle. On an assignment that I gave you in 17.1, you also have to state the quadrant. So let's just do that for fun right now. The quadrant that the angle is in is based on the terminal side. So you would say this angle is in quadrant 2. Now you remember how to label these quadrants, right? So this would be quadrant 1, this would be quadrant 2, this would be quadrant 3, and this would be quadrant 4. So our angle is in quadrant 2 because of the terminal side. This angle is in quadrant 3 because the terminal side is in quadrant 3. So these are all things you're going to have to do in the very near future. This is the initial side, terminal side, initial side, terminal side. Let's talk about a positive angle. Another vocabulary word. All right, a positive angle is a ray that is rotated counterclockwise. So it's the rotation of a ray, the angle is created from the rotation of a ray counterclockwise. Counterclockwise. A negative angle is an angle created when the ray is rotated clockwise. So I'm not going to draw a picture for these. I'll just show it over here. So like I said, this is a positive angle because the ray is rotated counterclockwise. This is a negative angle because the ray is rotated clockwise. More things. So note, an angle's terminal side determines what quadrant. The angle lies. I already mentioned that, but there it is in writing. If the terminal side lies on the x-axis or y-axis, in other words, the terminal side isn't lying in a quadrant, it's lying on one of the axes. If the terminal side lies on one of the axes, the angle is called quadrantal. Quadrantal, quadrantal angle. So if the terminal side lies on the x-axis or y-axis, the angle is called a quadrantal angle. Make sure you put that in your definitions for the vocabulary. All right, I mentioned this before, but I'm going to put it in writing now. When you're naming angles, there are two ways to name an angle. When we talk about right triangles, you're going to use Greek letters, you're going to use uppercase letters. So with right triangles, we're going to label the angles A, B, C. And you saw that in geometry. You saw the triangles labeled A, B, C. When we're naming angles in trigonometry, we mostly use the Greek letters. And I don't care which ones you use whatever ones you want. Well, there are some you shouldn't use. Don't use pi, because pi is a number. Don't use, what else? The sum one. Which one is the sum? I don't see it right now. Yeah, for now, just don't use pi. There's other ones you don't want to use. Oh, yeah. Which one is it? Well, there's one that looks like this. That stands for a sum of things, so I wouldn't use that one either. But with the lowercase letters, you're pretty much okay. So things like alpha, beta, theta, phi, whatever letters you want to use, you're going to use those to name angles. All right, let's stop there for a minute, talk about a few things. Let me erase these boards. All right. Okay, so you took an exam the other day and the scores were high. I was expecting that for a lot of different reasons, but I do want to talk about the exam, and you need to listen very carefully about future exams, all right? I wrote this in the stream of classroom. I also wrote it in the next exam that you're going to be taking on Monday afternoon at 2:30. Monday the 27th at 2:30, exam 16-1, 16-2. You had an assignment due last night, right? 16-2 is due at 9. I'm probably going to also put this in an email. I'm going to put in a remind message, because I want to make sure everybody understands this. Okay. In order to receive credit for problems on an exam, the scratch paper must be submitted. Now, I'm going to take this to another level this time. Okay, so I was pretty lax and lenient with these last scores. Some of you are doing amazing work. And actually you're setting the students who aren't doing it up for this conversation. So those of you who are doing amazing work, you're showing the work, I'm not talking to you, all right? So you must submit the scratch paper and you must show legible and correct work. Because I saw, honestly, a lot of garbage. I saw, you know, a problem worked in one step, and there's no way you could work a 5-step problem in one step. So that's not going to be accepted on the next exam. So if problems require work, you must show your work. If you don't, you're going to get a 0 on that problem. I'm going to grade it by hand. So after the scratch paper is graded by hand, then I will post it to Zangle. So you must show your work. So just like in our classroom, when I gave you exams and you had to show your work on the exam, you have to do the same thing. And if you don't do it, I'm not going to give you credit for it. And I don't care what the exam grade is. So let me make this really clear. If you got an 86% on an exam and you don't turn in your scratch paper, you're going to get a 0. Even if you turn it in late, you're going to get a 0, because from now on, I'm not taking any late work either. So for some reason, some of you think that you can turn in things late and it's okay because we're online or something, but my rules still hold. So I've been lenient, and now you can't turn anything in late. So when you turn in your scratch paper for the exam, I'm going to grade it. Okay, so regardless of the grade that you get, don't get too excited until you look on Zangle, okay? Because I'm going to look at your work, and I'm going to look at it closely. And I'm going to make sure that you wrote the original problem, that you're working vertically and you're showing correct work, and that you're circling your answer, just like I required in the classroom. I hope you understand that. Like I said, I'm going to put it in a lot of different places. I put it in the stream on Classroom. I put it in the exam in Classroom. I'm going to put it on Remind. I'm going to put it in the email, and you better do what I'm asking, because the buck stops here. So I'm just letting you know. So in line with that, I'm not accepting any late work from here on out. So you turn in an assignment an hour late, I'm not going to grade it. You turn in scratch work 2 minutes late, I'm not going to accept it. So pay attention to the requirements, pay attention to the deadlines. If you do not understand what I'm requiring, please contact me and I'll be happy to go over it. But you must do what I'm requiring you to do at this point. So no, absolutely no late work, no late scratch work. If there's an extenuating circumstance, I'll be happy to speak with you about it, but you got to let me know before. I'm not going to, right now there's a few people playing games with me, and I'm so over it because they're causing me a lot of work, and it's just, I'm not going to be taking any late work. Some of you are submitting assignments, the assignment percentage, with 2 forms. If you don't know how to do it, if possible, I just want 1 form. I just want to record it. I just want to see the assignment grade and record it. I don't want to see a lot of different forms. So maybe you can ask somebody what they're doing. The majority of my students are turning in 1 form, regardless if they're using a phone, whether they're using a Chromebook, or they're using a desktop, or they're using a laptop. Most of my students are turning in 1 assignment percentage. And those of you who are not, you can find out from somebody what they're doing. That would be greatly appreciated so I could record things easily. Okay, so I think I already mentioned this. 17.1 is a lot. I don't know how long it's going to take me to teach it, but I will be telling you what to do in a progression of assignments in 17.1. So I've shown you the Greek alphabet. So this is in video and notes. There's a sheet that looks like this, which you will not be able to do until I teach you and show you how to draw a name and angle in standard position. So this sheet is important. Make sure you do it. If you notice, all the problems on the left are in radians and all the problems on the right are in degrees. As I mentioned, you will be taking a quiz. It'll be in Google Forms on vocabulary, which will be incorporated into your 17-1 exam. So I'll let you know when that is. And I also included the answers for Module 17 in the answer section of Classroom. I think that's all I want to say. Let's continue on. All right, does anybody have any questions? You can just open up your mic and ask me. Any questions about anything?
Ms. Birch.
Go ahead.
So I think there may be a little confusion because for the test, when you said to turn in the scratch paper for Google Classroom, it says it's due till 4 p.m. So I feel like people are thinking that, oh, I have that much time, so I'll just turn it in from that time frame.
Yeah. Well, first of all, there was confusion about the length of the exam. So you only have 50 minutes in the exam. So for example, the exam, like on Monday, will start at 2:30 and it will knock you out at 3:20. So you only have 50 minutes for the exam. Now, so far I've allowed 40 minutes to turn in your scratch paper, but that length is gonna diminish. I'm gonna make that time less and less. So the reason why I'm giving you until 4 o'clock to submit the scratch paper is just in case you have any technical issues. But what you should be doing is this. You should finish the exam at 3:20 and turn in your scratch paper immediately. So some people did not turn in their scratch paper at all, and some people turned in their scratch paper a day or two late. Those people that are doing that will get a 0. So make sure that you understand the requirements. If you do not understand the requirements, let me know. But that time frame that I'm allowing you to submit the scratch paper, it's going to get smaller and smaller. So it could get all the way down to 10 minutes that you have to take a picture and submit your scratch paper. But I'm giving you some extra time right now to submit the scratch paper. That number will get smaller and smaller. Anything else? So in case you don't understand what I'm saying, you need to not be late for the test. You only have 50 minutes to take it. And at 3:20, it will stop. And whether it looks like it stops to you, I'm definitely seeing it on my side because I defined it that way. It will stop at 3:20. So, and then you're going to submit your scratch paper right away. Any other questions or comments? Okay, thank you. All right. This could be on the quiz also. There are 2 ways to measure an angle. The first way is what you studied in geometry, and that is degree measure. The second way that we're going to do 99% of the time in this class is going to be radian measure. So those are the 2 ways to measure angles. Degrees is actually more difficult because we're not going to have these perfect angles like you had in geometry. We're going to have angles that are not so perfect, and you're going to want to know how to measure an angle in radians because it's going to be a lot easier. So right now, I just want to do a review with degrees because that's what you feel comfortable with from geometry. So, you know the degree symbol, right? It's this little symbol. And let's just talk about this real quick. All right, I mentioned this before, but it's worth mentioning. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. You're going to use quadrants extensively. Make sure you don't get them mixed up. Okay, so if we're talking about degrees, and this first section, we are focusing on the unit circle. And I do know you guys were exposed to the unit circle in geometry. Unit means 1. So we're talking about this radius being 1. Now in trigonometry, we will work with circles with different radii, but right now we're talking about the unit circle. Unit means 1. So this radius is 1. Now, if we were looking at a 0-degree angle, that would be an angle that initial and terminal side is the same. So in other words, there's no rotation of an angle. You all know what a 90-degree angle looks like. So that would be the initial side here and the terminal side there, and it forms a right angle. A half a revolution would be a 180-degree angle. If you go from standard position from here to down here, that angle would be 270 degrees. And a full revolution would be 360 degrees. Now, it doesn't stop there. I mean, I could make an angle that does this type of thing. So I could keep going. I could go 360 plus 90 is what, 450. And so the way you're going to show this rotation is by, drawing your arrows. So if you were going to draw that angle that I'm talking about, you would have to draw a rotation like that. So that would represent a 450-degree angle. So there's infinite angles. You can rotate, keep rotating. In addition, you can go the other way. So if I do a negative angle, if you go this way, this would be negative 90 degrees. This would be negative 180 degrees. This would be negative 270 degrees. And a full revolution clockwise would be negative 360. And if I went 90 more degrees, it would be negative 450. Questions about that? So this is a review from geometry. You should know what an acute angle is. A right angle and obtuse angle and a straight angle. I would make sure you know this for the quiz. So an acute angle, and I'm just going to use theta, is my angle. An acute angle is less than 90. Now notice that doesn't say less than or equal to. It's strictly less than 90 and greater than 0 degrees. So this is a good way to write it. Less than 90 and greater than 0 degrees. A right angle is straight out 90 degrees. An obtuse angle says that the angle has to be less than 180 degrees and greater than 90 degrees. And finally, a straight angle is one that measures 180 degrees. So these are definitions. I would make sure you know them for the quiz. You never know when one's going to show up. All right, so all of this is what you did in geometry. You learned a lot more than that, though. You learned that an angle like that was 45 degrees. You learned that an angle like that was 60 degrees, so on and so forth. You learned an angle like that was 30 degrees. You don't need to know that right now. Don't worry about it. So if you were trying to draw different angles, you have to divide into parts. Half of 90 is 45. You know, a third of 90 is 30 degrees. I will show you how to draw and name an angle, and I'll give you specific steps for that. Don't worry about that right now. All right, now we're going to go into Radian Measure. And like I said, if we were at school, we would spend a whole day doing an exploratory activity on what 1 radian is. So I'm going to give you this definition first. It's not going to make any sense, but then I'll try to explain what I'm talking about. Okay, by definition, it's a very formal definition, the measure of the central angle theta angle theta of a circle that intercepts an arc, and we're going to call that S, that is equal in length to the radius. R of the circle. Yeah. So most students, you know, seeing this don't understand what it means, but somehow today I have to convey to you what this means. So hopefully you have an understanding about what this is saying. I'm going to draw you a picture right now. They're saying that theta is a central angle. They're saying that R is the radius. And they're saying that S is an arc length. So I'm going to draw a picture. All right. What? This is the radius, right? And right now we're talking about the unit circle 1. But this could work with any circle. It could be a radius 2, 2.5, 7. You go outside and draw a big old circle with a radius of 9 feet, 100 feet. It doesn't matter. This applies to the radius of any circle. When the radius is equal to the arc length, and you wouldn't be able to measure that with a ruler, by the way. You can't measure an arc with a ruler. You'd have to use string. And when I do this exploratory activity, I let kids use a protractor and a ruler and scissors, and whatever else they want. But a lot of them don't ask for string, and string is what you need. So when the radius of a circle, of any circle, equals the arc length, you get this angle. And this angle is 1 radian. And so if I, over here, if I drew a circle this big, that's not the same radius, right? Totally different. So now this is my radius. If I took a string and I measured the radius, can't use a ruler with the arc length. You use a ruler with this, but you need a string. And you measure the string to be this. That angle is this angle. So in other words, if I could take this off the board and I could superimpose it on this, you're going to get this angle. See my hand? So everybody with your left hand, show me 1 radian. See it? And if I take my hand over here, look. Now, we don't care about the degree measure of this angle. In fact, if you ask me, what's the degree measure of 1 radian? I don't know. We can figure it out, but I don't care. We don't care about the degree measure of 1 radian. All we care about is that 1 radian is that. And regardless of the radius of a circle, as long as the radius equals the arc length, as long as the radius equals the arc length of a central angle, you're going to get 1 radian. Now, here's the deal. So what's the big deal? What am I so sprung on with this? Well, you're going to be measuring angles in radians, but it's not going to be perfect. It's not going to be 2 radians, 4 radians. It's going to be pi over 2 radians. It's going to be 3 pi over 12 radians. It's going to be 7 pi over 9 radians. So it's going to be parts of a radian. So right now, it's just important that you know that 1 radian looks like that with your left hand. And that's all you need to know right at this moment. So what's the definition of a central angle? A central angle is an angle whose vertex is at the center of a circle. I'm going to start using this notation to mean circle. So you should have seen that in geometry, but sometimes I'm going to use that, so I'm just letting you know. So I'm going to use that to mean an angle, and I'm going to use that notation to mean a circle. So for example, if I ask you to show me 2 radians, there's your ring. Couldn't you just hold up your hand and draw 2 radians? So couldn't you say that 1 radian is about that, and another radian is about that? So that's 1, that's 2 radians, and just show it like that? Good enough. About 3 radians. I don't know, hold up your hand. There's 1 radian, there's 2 radians, and there's 3 radians. So let me ask you this question. I want you to open up your mic and tell me, what is the measure of a 180-degree angle? What is the measure of a straight angle? You know that this is 3 radians, right? We're almost there. This is the straight angle, right? What's the measure of a straight angle in degrees? 180, right? 180 degrees? What's the measure of a straight angle in radians? Go ahead and tell me.
Pi.
Say it again.
3 radians in pi.
It's pi radians. Yep. So now you've just discovered where pi came from. So for all these years, teachers have been talking about pi, but I don't know if any of them ever told you where the number came from. So if you were wondering, where'd they get this number? How'd they get 3.14? Look over here real quick. Isn't this 3 radians plus a little bit more? And that little bit more is 0.14. So a straight angle, and so you would say pi radians, because pi is equal to 3.14, right? Now we never see anybody say pi radians, but that's what it is, and that's where it came from. It's 3 radians plus a little bit more. So what would a full revolution be in radians? So a full revolution in degrees is 360 degrees. But how many radians would that be?
2 pi.
2 pi radians.
2 pi. Yep, 2 pi radians. 2 pi radians. So let me just show you this real quick. Something that's going to be very important for you to know in helping you is something that I call landmarks. And here are the landmarks. This is 0 radians. If I go half a revolution, that's going to be pi radians. If I go a full revolution, it's going to be 2 pi radians. If I go a full revolution plus a little bit more, it's going to be 3 pi radians. If I go a full revolution and come all the way back here, it's going to be 4 pi radians. Do you guys see a pattern here? So sometimes, rather than just rotating like that or over and over again, I use these as landmarks. So if they wanted me to graph 7 pi radians, I know that the even radians are over here and the odd radians over here. So I would say, okay, well, I know that if I was going to draw an angle that's 7 pi radians, I would say, okay, that's 2 pi radians. That's 4 pi radians. That's pi radians. That right there. And I have to draw the terminal side, and I'll label it beta. This represents an angle that is 7 pi radians. So it's going to be useful to use these as landmarks. One thing that'll be useful. I'll draw one more picture here. There's your 1 radian, 2 radian, your 3 radians, your 4 radians, your 5 radians, kind of off. Got to measure with your hand. 5 radians, 6 radians. So this would be 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, 6 plus a little bit more, right? Because isn't 2 pi equal to 3.14 plus 3.14, which is 6.28? And isn't this showing 6 plus a little bit more? All right, enough is enough today. I haven't really gotten to anything yet. The next lesson is going to be super important because I'm going to be talking about common angles, and I'm going to show you how we're going to divide the circle into parts in radian, and we're going to draw and name an angle in standard position using radians. So for now, there's really nothing for you to do other than to do the vocabulary. So make up your own index cards, write the word, make sure you study that. It's going to be critical that you understand the language that I'm speaking. And like I said, you will have a vocabulary quiz that will be incorporated into the exam grade for 17-1. So nothing to do except do the vocabulary, make sure you do it. All right, I'm going to turn the recorder now.